Hi everyone, this is Kelly and I'm here with my power algebra.
Look at the camera.
Oh. Hi everyone, I'm Kelly and I'm here with my power algebra teacher, Mr. D, to talk about scientific notation. So Mr. Drexler, what is scientific notation anyways and why is it used?
Thank you, Kelly. And yeah, scientific notation. It's something that some people struggle with, and I'm glad you're tuning in to see what we have to talk about. Scientific is very important because it allows us to write very large or very small numbers in a much better way, right? Let's say, for example, you're a scientist, okay, and you have to deal with this, speed of light number that keeps popping up. Let's say you have to write a paper or a report, and you have to keep writing this ridiculous number, this speed of light, which happens to be, do you remember that number there?
Yes, it's 671 million miles per hour.
Wow, very good. Okay, yeah, speed of light, 671 million miles per hour. Are you kidding me? If you're a scientist, are you going to want to keep writing that number over and over again? That would be kind of a pain after a while, wouldn't it? So, we take this number and we say, okay, it's the speed of light, all right, and a scientist is having to keep writing this number over and over again. I think it'd be much more convenient to write it in
scientific notation.
Scientific notation, much easier, and Kelly can help us do that. All right, so let's see, how would you write that number in scientific if you had to, and how would we better use that number? So she's going to write that down for us real quick, and we'll take a look at, see how that comes out. So, and we'll explain this as we go. All right, so let's see. Here's what she wrote down. Okay, we have, and if we can get close in here, 6.71 times 10 to the eighth power, and that looks correct. Very good. Okay, and now Kelly, here's the thing. Sometimes when people do this, they say, okay, well I thought it was 10 to the sixth power because isn't there 6 zeros? Do you remember, like, is it how many zeros you have, or?
No, it's how many times you have to move the decimal.
Very good. Very important. Okay, so make sure you guys, if you're doing scientific notation, okay, it's not how many zeros you have. If it is, it's just a coincidence. It's how many times you have to move the decimal point, as she said. And by the way, I noticed a couple other things here. Is there a reason you stopped at the between 6 and 7? Why do we say 6.71 and not 67.1? The reason for that, the number has to be between
1 and 10.
Exactly, right? The number has got to be between 1 and 10 in order for scientific notation to be written correctly. And I noticed you used a positive 8 here on the exponent. Is there a reason for that?
Because the number is bigger than 1.
Okay, we have a big number, we use a positive exponent. So that's the rule, guys. Make sure if you write in scientific notation, to write it correctly, you need the first number, which, by the way, do you remember what that's called? These things have names here.
Yes.
What's that called there?
Coefficient.
Okay, good. Coefficient. This is known as the
base.
The base and
exponent.
Okay, so we got the 3 parts to scientific notation. Terminology, very important as you're working through these. Coefficient number has to be bigger than 1 but less than 10. Okay, very important when you're doing that. All right, so let's talk some other scientific notation numbers real quick here. Let's see. Have you ever been to McDonald's or? Yeah, once or twice, maybe. I've been there. Yeah, I went there one time. It's a special occasion. I got an A, and so we took a trip to McDonald's, and they claim that they served 99 billion times there at McDonald's. Over 99 billion served. Now, if you're a McDonald's executive and you're writing a report, are you going to want to keep writing 99 billion every time? Okay. So what's a better way to write that if you're writing a report? A better way to write 99 billion. Let's see what that would look like in scientific notation. And she's working through here, counting up her. Okay, so let's see what she put down. All right, so let's take a look at this. We have, if we can get a close up there, it looks like 9.9 times 10 to the 10th power. And again, very good. Nice job there. And again, notice there were 9 zeros, but she said 10 to the 10th. Again, you always have to watch that. Okay, so she moved the decimal point. Always starts here at the end. It's always at the far right if you don't see it. 3, 6, 9. Took 10 places to move to between the 9 and the 9. 9.9 is barely less than 10, so that just made the cut, but it made it. And so there it is. All right. So what would you rather do if you had to keep writing this number again? Would you rather write this all the time or that?
That.
We see the huge advantage to scientific notation already. So look at that. All right. So scientific has big advantages. Looking at a very small number now. What if we've seen some big numbers? Let's see what a small number does. The mass of an atom of oxygen, probably pretty light, right? I mean, it's as light as air, right? I mean, obviously. The mass of an atom of oxygen, interestingly enough, yeah. How small is that number right there?
Really small.
Yeah. Pretty small, right? Just about, again, if you're a scientist, really, are you going to seriously want to keep writing that? Or would it make more sense to use scientific?
Scientific notation.
Obviously. Okay, and to save on time, in the interest of saving time, we went ahead and just already did this for you. Check this out. In scientific notation, that ridiculous number would just simply be 2.66 times 10 to the negative 23rd, okay? So again, for convenience, for a lot of good reasons to use scientific notation, these very large and small numbers show up all the time, and so that's a better way of dealing with those. Okay, so to summary, if you had to switch from standard form, as we've been doing, to scientific, Kelly, what's the best way to do that, to summarize that up for us here?
To convert from standard form to scientific notation, you move the decimal point until you get to a number between 1 and 10. Then you write that number without the zeros, times 10 to the however many times you move the decimal point. The base is always 10 and the exponent positive if you're working with a large exponent when dealing with a small number smaller than 1.
Okay, so there it is in a nutshell. All right, so if you ever have to convert from standard form, a very large number or a very small number, into scientific, that's the way to do it. Okay, so now you might be asking yourself, well, that's great, but I don't have trouble doing that. I have trouble going from scientific back to standard form. So let's talk about that for a minute. What about converting back the other way? Kelly, how should you do that? So let's take a look at an example real quick. Let's say it's already in scientific notation, like this, 5.71 times 10 to the 5th, okay? And you have to write that in standard form, okay? Would you go ahead and try that for me real quick? We'll see what she comes up with here. Be a similar process, except just going back the other way. So again, you have to watch, the direction you're moving. Sometimes people get into trouble when they do this. They get caught up in the right-left thing, and you want to be careful. Just the best advice that I can give you on that is a very large number is always a what kind of exponent? Large number, positive exponent. If it's a very small number, it's going to have a negative exponent. That's the rule, okay? So she noticed that this 5 was positive 5, which meant we were dealing with a very large number, right? Okay, so that indicated that we need to move to the right, which she did. 571,000 is correct. So from scientific notation into standard, okay? Again, move the decimal point whichever way you have to. If it's a positive exponent, that's a large number. That tells you have to go to the right to create a large number. Fill in the zeros as they're needed, right? And now, okay, let me ask you this, though. That brings us to this situation. What if you have a negative exponent? In scientific, you have to convert that to standard form. Okay, 2.86 times 10 to the negative 6th. So Kelly, help us out with that. See how you would do that real quick. This one a little different. And again, this time we have a negative exponent. So let's see what she does with that. And it looks pretty good from first glance here. Let's take a look. All right, so we have 0.0000286, and that is correct. Very good. Notice she did not put 6 zeros back here. Again, similar to before where, the number does not mean that's how many zeros you had. It took one of those 6 just to move to the other side of the 2, right? And then you had to go back 5 places. She filled in zeros as needed, and the decimal point winds up in the far left where she has it. Good. Okay, so there it is. To go either way, from standard to scientific or vice versa, that's what we're looking at. And Kelly, if you go ahead and summarize that for us, if you need to go from scientific then back to standard, what would we do?
To convert from scientific notation to standard, look at your exponent first. If it is positive, that indicates that we are dealing with a large number, bigger than 10 at least. So we need to move the decimal point to many times to right, adding zeros as needed. If the exponent is negative, that indicates that we have a very small number, less than 1. So this time, move the decimal point too many times, adding zeros to the left as needed.
Very good. Okay, so there it is. And again, if you're having trouble with scientific notation, whether you're going from standard to scientific or back the other way, hopefully those helpful tips from Kelly will help you do the right thing. Now, a couple things too. If you didn't get enough information from what we talked about today, there's some really helpful websites that we can go over real quick. Kelly, can you help us with those? Where would people go if they want more information on this?